In this video, we're going to look at some of the December 2018 exam problems as suggested from the check-in poll last week. So we're going to start off with the multiple choice questions, and one of the first questions that was selected was question number 6, where we have a function that has a global maximum at a point, and we're asking what can be inferred about the two constants in that function, the a and the b. So first off, I've put a little more room here so we can navigate. We have our function, which is e to the negative x minus a in brackets all squared over b. And we know that f of 3 is 1. And we also know that f prime of 3 is going to be 0, because we were told that there's a global max for the function at that point. And of course, if there's a global max there and the function is continuous, then we're going to have a critical point there. The slope is going to be 0. So let's see how these two pieces of information play out into information about a and or b. So let's use f of 3 equals 1 first. If that is the case, then our function value is 1, and that'll equal what we get when we sub in x equals 3 into our formula here. So 3 minus a all squared all over b. All right. So some people might just look at this and recognize that if we have 1 on the left-hand side, the right-hand side also has to equal 1, and the only way for that to occur is to have e to the 0. And that gives you an equation for the exponent there. If that's not immediately obvious, that's fine too. We still know we need to solve for a and b, and the natural way to do that, given that they are in the exponent, is to take the logarithm of both sides. Now, natural logarithm of 1 is 0, nice and simple, and then the ln and the natural base e are inverses of each other, so we end up with just the exponent, and we end up exactly the same place we would have if we'd set the exponent equal to 0 here, and then we start solving. We can't solve for b, because I can multiply the b up, but we do get 0 equals negative 3 minus a all squared. That means 0 is the same as negative 3 minus a squared, and then take out the square root of both sides. 3 minus a is 0, which means that a has to equal 3. All right, so the first piece of information, the point location, we can learn that a equals 3, and fortunately that's in our list of things here. A equals 3, but we can't tell about b, or a equals 3 and b equals a half. Well, let's see if the other piece of information that we have, the fact that we have a global max at that same x-coordinate, if that can help us. So to use f prime of 3 equals 0, we need f prime of x. We need the function. Well, where's our function here? There's our exponential. We're going to differentiate that, and that's going to give us the same exponential back. Derivative of any exponential is the same exponential back. And then the chain rule says differentiate the inside. Here it's the exponent, and remembering that x is our variable, so b's are constants, a's are constants. We get a negative 1 over b multiplier, and then the derivative of x minus a squared is 2x minus a to the 1. All right. And then we're now going to set the derivative at 3 equal to 0, and that's going to break down into this. I'm just going to move this a little bit, give us some room for the exponents. So we're going to sub in x equals 3. So notice where the x's are. They're here and here. So we're going to get e to the minus 3 minus a squared all over b times minus 1 over b times 2 times 3 minus a. And in fact, we know a too, so let's do that at the same time, 3. So we actually have, simplifying that as e0 has to equal e to the 0 times minus 2 over b times 0. We actually know that the 3 minus 3 is 0. And once again, b can be anything, as long as it's not 0 itself. It can be any positive quantity. So if b is 5, this equation is satisfied. If b is 10, that's satisfied, and that leads us to, we can't specify the value of b given the information that's provided. The only thing we can learn about is the a value. So not D, but B. Moving along, the next question that was recommended was the question number 8. A graph is defined by the relationship here. So this is an implicit equation for a function, and if that's the case and we're trying to find the slope of a tangent line, well, that's exactly what we mean by dy dx. We're going to use implicit differentiation to get to that point. So we start with our equation, and just leaving a little room here so we can clearly identify what we're transforming. We're going to take the derivative of both sides with respect to x. The right-hand side, that's fairly simple. We just get 0 as the derivative of 1 by itself, and the derivative of e to the x is e to the x again, with a negative sign out front. The other side's a little more complex. We have sine. The derivative of sine anything is cos of the same thing. Then we multiply by the derivative with respect to x of the inside, and that's going to give us 4 dy dx. Notice, because y and x are different variables, we would have the derivative of the inside function as part of our solution here. All right, then we sub in the location where we're trying to find the slope. Well, that's 0, 0. So what does that give us? That gives us cos of 0 times 4 dy dx is equal to minus e to the 0. And that, well, cos of 0 is 1, e to the 0 is 1. That gives you dy dx equals, don't forget the negative, negative 1 over 4 at the end of the day, which puts us firmly into the B category there. Last but not least, number 9 was another question asked about. And here, the main thing is to remember what we're evaluating. We're asked to evaluate the integral of cos of 5t plus t to the 5, plus t to the 4 rather, getting ahead of myself there, plus t to the 4, and that would be with respect to t. So one of these is fairly straightforward. It's one of our rules. Add 1 to the power, divide by the new power. The cosine of 5t, it's actually very similar to what we did here. We took the derivative of sine, we got cos. So if we integrate cos, we're going to get sine. It's going to be of the same function. We're still going to have the 5t in there. But notice when we differentiated, we end up multiplying by any constant inside the function. When we integrate, we're going to do the opposite, and that'll give us dividing by 5. And last but not least, of course, is the plus c. So if we scan down our list of options here, that looks like option C for the answer. If you're ever in doubt, what you can do is take the derivative of what we just found, and it has to equal the cos of 5t plus t to the 4. And you can check that term by term, and it indeed does, but it also reassures us that one of the answers in the option list satisfies what we're looking for.